we were talking about salts, and there are things about salt that they allow electricity to flow through water, that they are also are very important in our nervous system and our muscles. For them to function properly, they have to have the right amounts of sodium and calcium and potassium and some of these other electrolytes. That's why Gatorade puts those things in there, and that is why it's important to have those things if you're getting short on them. Like Gatorade was invented in South Florida, where they were doing football practice for 4 or 6 hours a day in high humidity, and they were in fact losing a lot of their electrolytes. Okay, and so they came up with Gatorade for that. But also in a lot of medicines, you say like pseudoephedrine, which is basically Sudafed. You'll see at the end of it, you'll see hydrochloride, and you think, why would I want to have hydrochloride, or basically hydrogen chloride, hydrochloric acid? Why would I have that added on there? And it's not hydrochloric acid, but it's hydrochloride, and so it's HCl. And but what happens is when you add this to a medicine, basically it's a salt of hydrogen chloride, so it's an acidic salt. We said some salts can be acidic, but basically you take the HCl and the H attaches onto the medicine, okay, which now gives it what kind of a charge? It's now positive charge because the hydrogen adds an extra hydrogen. It was neutral, the pseudoephedrine, but now that you've added the H on it, that gives it a positive charge. And if it has a positive charge, that means now this side of it is polar. It has a polar, at least on one side, and that will make it dissolve better in water, which, if you remember, water has hydrogen and oxygen. This side has a positive charge. This side has a negative charge. Now that it has a negative charge in here, before then it was nonpolar. Nonpolar will not dissolve in water. But now, since it has a positive side, it will be attracted to the negative side of the water, and it will help it to dissolve better in the water, and therefore be taken up into your blood that much faster. And so you will see this hydrochloride on a lot of medicines because it makes it dissolve better. All right. Now, another time we hear about acids and bases a lot nowadays, or going back to acids and bases, not just salts. We talk about acid rain. Okay, and with acid rain, the main problem is from pollutants. When we burn coal and fossil fuels and stuff, for other fossil fuels for our to make electricity primarily, although also our cars, the gasoline and so forth, probably contribute to that too. We start off with rainwater. When rainwater forms in the clouds, it's completely pure water, okay? But even as the water starts to fall down through the sky, it's going to have things start dissolving in it. And the main thing is carbon dioxide gas, okay? It's going to mix with the water coming down, which is a liquid, all right? And it's going to react, sorry, didn't mean equal sign, but that's kind of the same thing, and make H2CO3, which is a very, whoops, forgot to say there, CO3, which is a very weak acid, okay? And now this is, to be an acid, it has to be in water, so it's aqueous or dissolved in water. So rainwater is usually slightly acidic. It's usually from 5.6 up to the pH. The pH is either less than, and it's got to be less than 7. So generally, it's going to be greater than 5.6. It's not going to be, if it's more acidic than that, it's considered acidic rain. If it's 5.6 to 7, it's going to be considered just regular rainwater and going to be neutral. But keep in mind that most of the water is going to be probably up here closer to 7, but it could be as low as 5.6. If it gets any lower than 5.6, then we consider it acid rain. Okay, so anything less than acid rain would just be any water, rainwater, that has a pH of less than 5.6. Okay, and so if it's any lower than that, that's considered dangerous. Above that, it's acidic and it would have some effect, but not so bad. Now, how do we get acid rain? Well, instead of dissolving with carbon dioxide and stuff like it might in the air anyhow. Now when we've burned coal and all these things, they spew out sulfate, sulfur and oxygen added together to it, and nitrates. Okay. Now when they add with water, H2O, and now the hydrogen attaches to that, and so now we end up with H2SO4, which is sulfuric acid, same thing that's in car batteries. Okay, although obviously this would not be as concentrated as that, but still it's sulfuric acid, and that can't be a good thing if you get very much of that in the air. Or nitrate, the various nitrates are going to combine, and they may make nitrous oxide, which will be okay, but the main thing is, I'm sorry, redo that, and eventually they will react and form HNO3, which is nitric acid. This is the one I said that would eat at proteins and stuff, so that's probably not real good to have falling on you either. Okay, now, like I said, if it's less than 7, that's to be expected, but if it gets much lower than 5.6, then it's going to cause a lot of problems, and it begins to eat up statues and things that are exposed to it for a long period of time. Lakes, pHs may get so low that they start having fish die-offs and things like that. All right, so how do you fix this? Well, there are scrubbers, there's things called scrubbers, that can be put on the smokestacks. All right, and they can help clean out a lot of this. Okay, and they have. Most of them are usually getting close to 97, 98%, fairly high. I went to a coal mine and power plant and coal mine in Fairfield, Texas, between Dallas and Houston, and they had done a very good job of reducing those emissions. Okay, now the question is how much. Like they said, you can get to where it's 99, 99.5, whatever, but the problem is the more and more of these you try to take out, the more and more expensive it gets, and it costs money. Now, power companies are there to provide a service, but they're going to charge you for that service, and if it starts costing more and more to make the electricity, guess who gets to pay for it? They're going to have to pass that on to you as higher cost. Okay, now, their argument is that, so the question is how much is enough? Okay, and that's where people are going to have obviously have different points of view and arguments about it, because there comes a point at which, yes, you can get more of it out, but it's going to cost so much and raise the cost of electricity to the point that it may not really be worth it. Okay, now, power companies, on the other hand, say, see, just trust us, we'll take care, we've done such a good job, but they've done such a good job because there have been laws in place that have forced them to do that. 2, because there are places in Europe, especially in Eastern Europe, but used to be under communist rule, that did not have these type of protections in place, and you can see extreme damages to statues and buildings and forests that were exposed to extremely high levels of acid rain. We have not had, yes, we have had places that have been affected by acid rain in the United States, but nowhere near to the extent of some parts of the world. China is possibly someplace like that now. There are clouds and air movements that come across from China carrying stuff from China because there's so much emissions that they have. All right. Other things that we worry about, carbon dioxide, we talked about hydrochloric. And this kind of illustrates the nature of science, is that we think, oh, one thing's good, but then there may be some unintended side effects we don't really think about. We have higher and higher levels of carbon dioxide emissions because we have more factories, more cars and so forth, all emitting more carbon dioxide as they burn these fuels that contain carbon. Okay, and so there's no doubt about that. That's a fact. Okay, we are increasing the amount of carbon in the atmosphere. It's partly due to man. That is a fact. Now, exactly what's going to be the results of that 20 years down in the future to the climate, are all the storms and so forth just this year's variation of weather, or a short-term trend that's going up, or is it caused by it? That's where a lot of the debate comes in, but there's no doubt we're increasing that. Well, one of the things some scientists notice, but as the rain comes down and so forth, it picks up some of that carbon dioxide, and it makes H2CO3, okay, and it washes basically out of the air into the oceans. They say, well, good. That will lower the level of carbon dioxide levels in the thing, and that would be a good thing. Okay. The ocean will just absorb all of that. However, they found out that as this hydrochloric carbonic acid gets into the ocean, it dissolves a lot of the calcium carbonate and the things that little marine creatures use to make shells out of. Okay, and since it dissolves all that stuff, and it either dissolves so it can't be used, or it sinks down to the bottom where it can't be used, now you have all these little creatures that can't make their shells, therefore they die. Well, then the bigger things that eat them, little bigger creatures eat them, and eventually get to fish and so forth. And so that can really upset a lot of the food chain. So at first people thought, well, we don't need to worry about carbon dioxide because this shows that the oceans are absorbing a lot of it as carbonic acid, which is a weak acid, so it's not going to turn the oceans acidic, but it is dissolving the shells of animals, which is impacting their food chain. So it just shows that the world is a very complicated place, and so for one thing helps, one thing else may have a bad or undesirable side effect. How much will the increase in carbon dioxide, the greenhouse gases we call them, increase global temperatures? How will that affect the sea levels and the weather patterns? And how much are they affecting it even now? That part is partly up at a debate, but the future will definitely show us the answers to that. So future generations may look at us and say, why didn't they kick it into gear and fix it before it became such a bad problem? Or they may say, it really wasn't that big a deal. It did change the weather patterns. On the other hand, it could be very severe. So we'll just have to wait and see how that turns out.